Hi everyone, how are you? Okay, we have a few minutes before starting class. You can check out Canvas, look over the lab for a few minutes, and then we'll start, okay? Good to know that you're well. It's a little rainy outside in Moreno Valley. A little bit of spring shower. So while you wait, you can take a look at the lab from Canvas. We are doing lab 4. I also added an announcement in case you're interested in participating in a challenge to win $2,500. It's organized by Student Association for Cybersecurity. And they are also alliance with the Veteran Cybersecurity Education. So if you're interested, check out the announcement and then I'll talk a little bit about that shortly. Yeah, it's raining. It's good to have the rain once in a while, right? But yet, I don't think I can live in the rain for a long time. Um, when I finished my undergrad, after finishing my bachelor degree, I applied for Amazon headquarter office. I knew someone that started the project that what you see today on the Amazon website and app for video review. So I was one of the candidate that was interviewed for that team long ago. So as you know, Amazon in the business for a long time. Back then, they transitioned from selling books to more, broad-based product for the consumer. And at that time, they started to implement customer review and they wanted to transition it to video reviews. Now what you can see is people can upload video and pictures. So it started a long time ago. And they did offer me great moving packages and everything. And at that time, I got an administrator position locally and it paid a little bit higher. So I opted to stay in Southern California instead of moving to Seattle. Looking back, the decision you make in your life sometimes change the way that you function in life. And I don't regret all the decisions I made. I think it gave me an opportunity to grow as a person. And thinking now that if I was on that team, how my career would have been a little bit different than what it is today. I don't think that I would have gotten into education. The reason why I got into education was because somebody that I knew needed, somebody to teach a class, and I I got into that through working with these people and connecting with these people. So it's really important that you connect with people and establish your network as well. So you never know who's going to be able to give you that opportunity. So all right, 6 o'clock. So let's talk about some of the things that we need to address today. So let me get into screen sharing. Let me open up. I did have my lab open. Okay. All right. So before we start the lab, I wanted to point out that in the lab, I did include some additional tutorial video explaining about permutation, and it's really addressed for computer science. And then in the announcement, as you know that I'm I'm just awed on how much demand in this field for different technical professionals. So if you are in computer science, you can definitely gain some experience in cybersecurity. And this is a challenge that I just posted. Um, this one is you can win $2,500, and if you're familiar with bug bounty, it's very much like that. So supply chain companies are looking desperately for people who help them with fixing some of the security issues, from their system to devices to network infrastructure to cloud environment. And a lot of the things that we do is pushed through the web. So having the programming knowledge is going to help you quite a bit. Okay. And then understanding encryptions and also networking is a big core in cybersecurity. So if you're up for the challenge, on the 20th of this month, which is a Saturday, I think they have a live event. And you don't have to be super experienced with programming if you know the language, if you have knowledge in some of this area. It's good to participate because employers sometimes come to these events and they become judges on these events, and they use it as a platform to hire people. As you know, that there is a huge demand in this area in cybersecurity in general. And according to New York Times, in 2021, there's 3.5 million jobs globally that relates to cybersecurity, and there's not enough people to fill it. So definitely a good option to look at. So check this out. If you're interested, you can click that to register for on Eventbrite, and then maybe take on the challenge. Okay. All right, so we are going to do the lab. And in the lab this week, we're going to pick up the the discussion and the concept in counting. And very similar to last week, we are going to take a look at how we would write these program in C++. And hopefully it will add to your technical knowledge. Okay. And some of you might have seen this before, but um, sorry. So lexicographical permutation in C++ is a way that we would shift character or text display in different combination. Okay. Even though we're using the permutation algorithm. And so this is a little bit different than last week in that it's going to implement we're going to use the STL that's going to implement functions, that built-in function for the STL that would allow us to display the combination of the number a specific way. But in this case, we're looking at order does matter. So that will really transition us to looking at permutation. So it talks about implementing next permutation and how we would look at the data in the container and be able to create variations of a subset of of the values in the container. And what we can see is that it's going to arrange the numbers based on the next permutation of the greater permutation of the number. So it must rearrange in such that the lowest possible value is in a specific placement. Okay, so it makes more sense when we start looking at the program. So here it gives you a little bit of definition on how it's comparing the value. So in the comparison, what happens is if you're looking at characters, they are usually encoded, right? UTF-8 or ASCII. So what you have is you have some kind of sorted container that would hold this value. And what we're doing is we are comparing the elements sequentially, looking at the position in that when it arranged against each other, that one element is not equivalent to the other. Okay, so if you're looking at like 1, 2, 3, if we rearrange that for the next permutation, the next output of this is going to be 1, 3, 2, where it won't be equivalent to the previous round. Okay, and then so therefore, if you look at the next one, you have 3, 2, 1, and then 1, 2, 3. So in using this particular STL, what you have is you will never have the next permutation that will be equivalent to the previous. So further on, it talks about using next permutation in the algorithm STL. So in this week, we are going to include algorithm, and it is, if you're looking at other languages outside of C++ like Python or Java, right? Python, that will be a module that we will bring in. And then for Java, that will be packages. But for C++, we're just going to include this library, the STL, and we're going to call on the function from that library. So that way we can reorder the arrangement, okay? Looking at the first element to the last element and how every arrangement that we're going to have is going to be different. And because permutation considered the order, where each of the order matters and each of the order should be different, each of the possible way that we set up the output or the order of the elements would be different. So when we look at the number of elements, which is your cardinality, it's gonna use the factorial of the cardinality, which is n. Okay, so keep that in mind that we are using permutation, and to calculate permutation, just like how what we talked about last time, right? We're gonna subtract 1 every time. So therefore we would, when we use the product rule with that, we would apply the factorial rule. So we would apply the factorial theorem. So in this case, what it's gonna do is it's gonna make the arrangement looking at the first compared to the last with the how it's going to be always generating a greater permutation compared to the last round. Okay, and we want it to make sure that it is sorted, okay, to start with, so that way it would be able to arrange. So and it talks about how all of the elements are sorted in ascending order to start, and the largest has all of its elements sorted in the descending order. So what does this mean? If you start with A, B, C, D, right? And the next round of that is going to be larger than A, B, C, D. And then the next round. So eventually it's going to shift all of the characters. And when we ended the program, it's going to be, backwards, right? D, C, B, A. Okay, so we're going to go from ascending, and then at the end, it's going to go descending. And the way that we calculate this mathematically is that we're going to look at the number of elements in our container, and we would apply the factorial to that. So if you have 5 elements in your array and you're permutating, what will happen is it's going to go 5 times 4 times 3 times 2 times 1. And so the possible arrangement that you're going to have is 5 factorial. Okay. Now, in the function, it talks about if the function can determine the next higher permutation, it rearranges the elements as such that it returns true. If it's not possible, going to the next page, it rearranges the element according to the first permutation sorted in the ascending order. So if it's not able to rearrange it where it would be larger, then what it would do is it would revert back to the first permutation, because that's how the function is created in this library. Okay. Any question with using next permutation function in STL? Okay. So when we're looking at this program, this is example 1, and this program is a little bit more complex than all the ones we've been doing so far. So as we go, we're going to see that we would apply, right, different STL and be able to write more complex program. So in example 1, this example is using an array. And in this, what you see is that the array is called myInt, right? And we initialize the array with the value for the elements starting with 1 and we go to 4. So we have 1, 2, 3, 4. So the cardinality of this array is what? 4, right? The length of the array is 4 elements. Okay. So nothing fancy in that we have include the algorithm at the top because we are using a function from that STL, next permutation. And with algorithm, you're able to use the sort function because remember that the next permutation relies on sort because it's going to start with the lowest and then it's going to end with the highest in descending order. So now like what we talked about last time, if you put using namespace std, then you don't have to include all the std here with the double colon, but if you're not, then you have to include it for the lines. So for line 8, what we're doing is we're going to take this and we would make an assumption that it might not be sorted, right? Because you might have a set and sets are not always are in order. But so in any case, what we can do is we can start with sort. Okay, so if you have an array and if you wanted to sort, you would use algorithm STL and then you would use the sort function. And in this, what we simply pass for the parameter is going to be the array itself and 4 elements of that array. So on line 8, that's what you have is you would start with the sort after you declare your array and assign value to it. Then next, we simply just output right? And since we have 4 elements, that would give us 4 factorial possible permutation of the elements is that it's going to do the calculation. Okay, so we simply say that it's going to be this. Okay, and then for in the next part, we're going to include a do while. Okay, so we're going to start with the first element and then we're going to have it send through. It's going to loop through and it's going to show, right, each of the element value for that would be represented starting with 1. So you would have the first element is 0, right? And it's going to count up the loop as it goes. So as you permutate for the next round, that's going to be count 2, count 3, count 4. And so for this part, basically, we use a loop to print out to access each of the element from that array, right? You're using an index value here, and the index is going to point back to the values that was assigned in that array. And that will be the do part. For the while is implemented with the actual function from the STL, next permutation. And when we're using this, and so you can also look at the comment, with the next permutation, we simply pass the array itself and 4 elements in that array. Okay, so what it's going to do, it's going to automatically use this function to rearrange all of those elements as it outputs. Okay, so we'll start with 1, 2, 3, 4, and then it's going to swap, right, the values to as long as the next permutation values are going to be higher than the previous. Okay, so the next one is going to be greater. Then at the end, what you would have is you would have a totally different arrangement where it would be descending order. And then after the loop, right, it's going to finish, it's going to show again your value for the access. So let's take a look at this program. I'm in the wrong folder here. Okay, so here's the next permutation. So I already explained the program in parts, right? And then when we run this program, so you can see. Now, if you're looking at the 5 factorial, right, that would allow us to determine the total number of permutation, right? So here we have 24. So if you take factorial of 4, you take 4 times 3 times 2 times 1, okay? Is that going to be equivalent to 24? It should be, okay? So as it finished out, so it started with 1, 2, 3, 4, okay? And in the next round, it's 1, 2, 4, 3. That is higher than the previous round. Then in the next round, it's going to go 1, 3, 2, 4, which is higher than round 2, and so forth. So as you can see, each round, right, when we're looking at the values, it's going to be higher. And it will continue to rearrange that until it reaches the max, which is the complete descending order. And then at the end, right, we just reprinted what we started with because that's what we did in the actual program itself. So at the end, we just simply access the array that we started with, right, which is 1, 2, 3, 4. So after all the loops, right, when it completes, it shows you that we have 24 permutation from the given elements in my int array. Okay, so now what you do is you can input that program into your IDE. So for question 1, it asks you, using the example 1 of the next permutation function, create the program in C++ that include an array of 4 elements and use the next permutation function. So you can use the same exact assigned value, or you can come up with your own array, right? But we wanted to make it 4 elements, so that way, you know, you don't have to fix the rest. But if you do have more, all you have to do is in the parameter, you just need to change it. So if I have 5, I would do a +5 there, and I would change up my program. Okay, so I have to sort 5 and I have to output 5, right? But in this case, we are required to do 4. So first, when we calculate this for 1A, we would see that the variation of the arrangement, we talked about this, it should match up to what we would see as output. So we would have a factorial of 4. And if you multiply that out, you would have 4 times 3 times 2 times 1, which is equal to 24 arrangements. Okay, so we simply do the calculation to verify that the program is actually giving us the appropriate number of permutation, right, using next permutation function. And I mentioned this in all my programming class, right? The program is as accurate as its programmer, its developer. So, you know, you cannot trust a program 100% because there might be a flaw in it, there might be a logic error, right? So going back and applying what we were talking about with counting, with combinatorics, we would see that when every time that you take one item, right? You selected an item, you remove it from the set. So therefore you would reduce by 1 and you would multiply it. So in this case, we simply use numerical or integers to represent our elements or our objects in the container. And using the next permutation, we just rearrange those objects, and every rearrangement subsequent of the first one is always going to be higher. Now, the first one going into it, we have to sort it, and because next permutation require that sort. Okay, so if you decide to use next permutation, it works best if it is pre-sorted. Okay, so you just simply sort it and then be able to create a loop so that way you can output. Okay, so after we do the calculation for 1A, run the program and describe the arrangement. And I already explained to you how each of the arrangement subsequent of 1 would be. And what did, looking at the program, what does it ended up with? So if we start with 1, 2, 3, 4, the next round, it goes to 1, 2, 4, 3, which is higher, right? And then the next round, it goes to 1, 3, 2, 4, which is higher, and so on. And it would change it, rearrange it to a higher output or higher permutation, and it's going to end up with completely descending order at the end. Okay, and that will be the last round. Okay, so we started with ascending. Okay, and we ended up with descending order of permutation. So for 1B, after you create and run your program, you can simply describe the arrangement of the elements. What does it show you? What does it show to you? And then take a screen capture. Okay, any questions so far? And you don't have to include all the comments. Okay, you can just simply write the code and be able to run the program. So there's a question asking, does the permutation display the Boolean value? In this case, if you're using this STL for the next permutation, bool values only have 2. It's either true or false or 0 or 1. So you cannot really permutate too far. It's going to start with 0, 1, and then 1, 0, and it will finish because factorial of 2 is 2. Okay. So in such case, you only going to have 2 permutation. So if you want to apply that to some kind of realistic case, probably not too, you can't permutate too much with bool type. So if you use bool type, you know that you're going to have 2 permutation. That's it. 0, 1, and 1, 0, or true, false, and false, true. And that's going to finish. Okay. So it works best with type like int, double, larger type, or even char for characters, right? We can try A, B, C, D, and so forth. Okay. And when you use character, it would be converted, right? So when you have A, B, C, D, A is equivalent to a value, and that value is then the compiler. It would take that, it would interpret that and bring it down to a numerical number. And if you wanted to reference like ASCII, right? An A could be 65, and so that in decimal, and that decimal gets converted to binary. So the computer, it rearranged this based on binary values. So each permutation would have a larger binary value for each round. Okay, so for C, right, after you write your program and take a screen capture and answer the question, don't forget to answer the question, then we would replace the first two elements and put in some higher values. So my example here is if I have 11, 12, 13, 14, I would change the first two to a higher value. I can put 16, 17 or 21, 22, right? Because I wanted to test the sort mechanism and the permutation algorithm in this. That's what I'm doing. So when you change it up, right, when it's sort, it should sort it, and it would the first round it's gonna go low, and then the next one it's gonna go higher, and the next one it's gonna go higher. So you can, if you're using 1, 2, 3, 4, you can put like 7, 8 in the front, or a higher value for the first two. And I want you to run the program and describe to me what the outcome of the permutations. Okay. What are the main differences? Are there any differences except for the values themselves? And then give me the screen capture. So we need to make an observation on that, okay? So let's say if I put in 11 and 12 here, because it's higher than the rest, and I rerun this, okay? So what we see is that it did sort it, right? We still have the same number of permutation because there are only 4 values in the array. And then what we also have is that you would see, right, that it is higher in each round. And then when you get to the end, it will be in descending order, just like before. But the only difference is in that we didn't start it with a pre-ordered set or a container. So again, for 1C, all you do is replace the first two elements with higher values, and you don't have to do it where they are also in order. You can put in 22, 21, or 15, 18, whatever you like. See if it sorts it, and then see if it's still going to give you from ascending and then ended up with descending. And is it greater every single time? Any question regarding example 1 and exercise 1? So question?
Yes. Will the arrangement ever change in numbers?
No, well, the arrangement will never change because we're using the next permutation in this one. It's always going to be a bit higher every single time if you're using this function. because the algorithm that's implemented for this function, it's designed to give you that every single time.
Thank you.
Mhm. We're going to look at other function in this STL so that way you have a feel of what it's going to be doing, right? And the whole point in this is to introduce you to library along with how to implement the function from the library for C++ for permutation, for, you know, in case you need it to solve a problem in your career or in your education. Okay, so the takeaway from this is that we explore how to use this STL and how to be able to implement a function from this STL to permutate with a group of values. Any other questions? Okay. So you saw how next permutation would be used and what would be the output. In number 2, we're going to go in reverse. Okay, we're going to use another function. And in this one, it's going to rearrange the object that's going to be smaller in every permutation. Okay, so earlier we saw that it's greater every time. Now in number 2, it's going to be smaller every time. Okay, it says that it rearranges the element as such the returns is true if it's not possible, if it's already at the lowest permutation, then if that was not possible, because if it's already at the lowest permutation, it rearranged the element according to the last permutation. So when it reaches the lowest permutation, it's just going to repeat the last permutation that it gave. That means that it reaches the max. Okay, so now the way it's sorted is that it's going to be sorted in descending order. Okay, so it's the opposite of the other one. Basically, that's what we're looking at. And the number of term permutation will be always the same. So if you have 4 element, that will still be 4 factorial, right? If you have 6 element, that will be 6 factorial. It doesn't matter which function you use. The number of permutation is really depend on your cardinality or the length of your array or the length of your container. So the different permutation can be ordered according to how they are compared to each other. And so first, if you started with the first sorted possible permutation, and what it would do is it would compare it lexicographically, it needs to be smaller for each round. Okay. And so it would rearrange the order, and the largest of all its element is sorted in the descending order. Okay. So in this one, what we would use the function called previous permutation, because the previous will be higher than the next round. Okay. So it's going to reduce every single time. Now, very similar to the previous, let me show you the previous example. We're going to look at, so it's pretty close. Okay. Only changes is the function that we're using. So that's probably just a small edit on your part, on your program. So this one, we are using the previous permutation function. So again, we're going to include we're gonna include algorithm, okay? And in the main, what we're gonna have is we are also gonna use what's called the reverse. So what we do here is after we declare our array and assign the value for the elements, we initialize the elements. Then, like the other one, we sort them, okay? And then we reverse sort. Okay, so what does that mean? This sort goes from 1 through 4. This reverse is going to give you 4 to 1. Okay, because remember, this program is it's gonna reduce every single time that it permutates. Then again, we're gonna have a cout, which allows us to display the string factorial of 4 possible permutation with the elements. Then we would have a do while, and we simply use this to print, okay? And then in the while, we implemented the previous permutation, and in the parameter, we pass the array and the number of elements. Then lastly, we simply access each of the element to show what we started with. Okay, so here we go, right? So if you notice in the last one, it start with 1, 2, 3, 4, right? In this one, it start with the highest one, and it's gonna go lower and lower and lower and lower and lower each time. So out of the 24 possible arrangement, each arrangement, you're gonna see that it's gonna reduce until the end where it's gonna be 1, 2, 3, 4, which is the smallest. And after the loop, we showed what we started out with, which is the first round, because we issued the reverse here. Okay. All right. Any question with this program? Okay, so for example 2, we are gonna look at the program. It contains previous permutation, which also contains 4 elements in the array. Just like 1A, you're gonna calculate the possible arrangement of the numbers in example 2. So how many numbers do I have? I have 4, right? I have 4 elements. So my cardinality, my n, is 4, right? Excuse me. And in order to find the total number of arrangement that it's going to give me in that program, that's going to be factorial of n, just like what we did before. So that will be factorial of 4, and you can see that also in the text output. And that would also be 24, right? Then for B, you would test the program, run it, and then you're going to describe to me the arrangement of the elements, what's happening. How is it different from the example 1 program? Okay, that's obvious. Okay, I've been saying what happens each round from example 2 compared to example 1. And obvious differences in that we're using the previous permutation in example 2 compared to example 1, we use next permutation. And the next permutation, what happens at the output? Give me a screen capture. Then after you have that and put down the explanation in the screen capture, just like what we did last time, we're going to replace the first two elements with the higher value. Then we're going to run the program and see what happens. Okay. And I put here, describe the outcome of the permutations after you change up the value. Is it still going to give you the same sequence like what you've seen? Okay. Is it going to be, descending order to start? Did it sort, did it reverse sort it, right? And then what are the main differences compared to the last one? Is it really different from the last question after you change up the number? And then give me a screen capture showing that you did run the edited program. So I can go in here and let's say I put in 21 and 22. And then I rerun the program, right? So it did reverse sort it for me to start. And then it reduces also each round. And by the time it gets to the bottom at the end, round 24, it would be completely in ascending order from smallest to highest. Any question with this? Piece of cake, right? So keep in mind that you will be introduced to STL and functions and how to use those things that would be applied to discrete math, right? And these things you got to use it and practice it. Sometimes if you don't do it, you forget. So the reason why I have you screenshot it, so if later on, if you look back in your notes, you're like, oh yeah, I remember I did that program that I used this. And so you can look at the code and you can look at your output. Questions? Okay. So make sure we include the explanation, screen capture, and then follow the instructions for example 2 or question 2. And we will cover sequence and series later on. So we will take a look at that and after we get into probability. And when you take a look at the STL, of course, there are lots more function that you can use, right? And it's always good to go, for C++, they don't maintain like a true documentation environment, but you can go to the C++ website and then look at, or there are a tutorial website where you can take a look at the function definition, right? How that's written. So it shows you, the template for that function. Other languages, they maintain better documentation repositories. So you can always go back to documentation and for all programming language, really. Okay, so we only have 4 things to do today. And right now we should be about number 2 if you're not there yet. So now if you don't finish tonight, no rush. You have a couple of days to go through the lab and, you know, redo it again if you wish. And then you can submit it. Okay. But if you finish tonight, you can always turn it in and you can worry about other things and enjoy your weekend. So I have some students are competing in the California Mayor's Cup for the Cybersecurity Challenge this Saturday. I know I posted some stuff in the announcement, maybe not for this class, but I'm presenting on Thursday. And there are a lot of really cool presenter that show from different companies like Booz Allen, Cisco, etc. So if you're interested, let me know. I can send you the link. Okay. Any question from 2 or 1? No question. Good. All right. So that means that if you didn't want to ask now, if you want to ask later, that's fine. Okay. So if you wanted to ask later on, that's okay too. But next, we're going to talk about is permutation function. So when we include algorithm STL, we can use is permutation. And what it does is it does the test of the sequence and by comparison using the equal. Okay. So what we can do is we can verify, right, if it's a matching permutation. Okay. So it says that it returns true if the first range is permutation of the other, otherwise return false. So it will allow you to check if it's the first range permutation from your container, from your given value. Okay, so let's take a look at the program. All right, so this one is pretty short and sweet too, right? You have include algorithm, that's the STL we're using. In the main, we have one array that's called ARRA, and in that array, we initialize 1503. The second array we have is array B, and we initialize array B with 0531. Okay. Then what we're going to do is we're going to implement a condition if else statement. It's going to check if array B includes all the array 1 element, and by just visually looking at it, you can tell they have the same values, right? And what we're going to do is in the if statement, we're going to check to see if it is a permutation. Okay. And in the parameter, we simply pass the array A, the elements of array A, which is 4, and then array B. So it's checking against A. And then we would, if it's true, after it checks it, then it's going to output B is a permutation of A. If it's not true, then it's going to bring it over to else and then it's going to output B is not a permutation of A. So this function is made for comparison, right? And we would have to apply it in a control statement. So when you run the program, it checks true that the B is a permutation of A, okay? Because we can go from 1503 to 0531. You can play with it a little bit. You can swap it around to see, right? The position of the element, does that really matter when it does the check? Okay. And if you wanted to be thorough, you can go to the website and look up the template for is permutation. Okay. So our program simply is checking whether one is a permutation of the other. All right, so for number 3, we are gonna look at that example. We're gonna look at how is permutation function used for both of the arrays, which they both contain 4 elements, but in different order. Then we're going to calculate the number of arrangement with the permutation for array A, and that's easy because we know that n is equal to 4, and n factorial is going to give us 4 factorial, which is also 24. We've been doing that for the other 2 as well, right? So once you calculate the number of arrangements, now we didn't output these arrangements like the other 2, that's fine. We know that each of these, if they permutate, they should have 24 permutations output, right? If they rearrange the order, we should have 24 round or factorial of 4. So after we put down the estimated arrangement or the number of arrangements, we would then run the program, describe the outcome, give me the screen capture. And then for C, I want you to change the element values of the second array to be different. So for B, you don't have to change all of them. You can change a few of them to make it different than the A. So change the value for the B and make sure they're different than A. Rerun the program and show the outcome. So it should check false, and it should go over to the else condition. It should branch to else and explain the outcome, provide the screen capture. So let's say that I put 10, 15, 13, and 11, right? And then I run. Okay, voila. It says that B is not a permutation of A because it did not check true here. So it's going to kick it over to the else, and then it's going to display the output for under, it's going to execute this C out, right? Because it checked false for this. So we simply just change up the value for B, and then we rerun the program, describe our output, take a screen capture for 3C. Also, the takeaway from this is permutation is using the given objects in that group and rearranging that object in such that order does matter, right? And the total number of arrangement is going to be the factorial of the cardinality of that set or that container. Any question? So no question for 3? Let me see a chat question. Okay, just a comment. Okay, good. These are pretty simple. But I don't, the reason why also is that, want to make sure that we are on the same page, we can see, we can understand this. In the past, I've used more complex programs in other semesters, and some students, they struggle with it and they're not grasping it. So I went back and I rewrote this. So these last 2 questions were revised compared to what we've seen previously. So every semester I rewrite stuff over. Okay. This one is a little longer, number 4. Okay. And then after number 4, we'll be done. Now, as far as, let me point it out, don't forget about stuff that we need to do this week. We still have a quiz. Okay, don't forget your quiz. And then there's the review game where you would have a chance to win a $25 gift card from Amazon. That's the limit that I can give as a faculty because they have a policy, anything 25 or below we can do. So if you do the quiz and you score the highest, and I do close these by a certain time, right? There's a closure. So I think it's by the end of the week after Sunday, it will be closed so I can get the winner. Otherwise, it wouldn't be fair. But you can still submit the extra credit by the 15th. So if you do the quizzes game, so it is very similar to your regular quiz. So if you look at it, some questions are slightly different, but it's a good practice quiz to do. And then at the end, you can look at the answers on there. You do have 2 attempts. And so I recommend doing the quizzes game first, kind of see what you need to review on. And if you do well on that, you can move forward and take the quiz. And I know some of you already started taking the quiz, but okay. And then before we do number 4, we have a chapter 8, part 2, where we're going to go a little bit further into combinations, and then we're going to review binomials and Pascal theorem. I know some of you learned that in your math classes, but we're going to wrap up. And this, we want to emphasize the lab a little bit more on combinations, as this week we would do permutation. Okay. And then we will proceed to chapter 9 after that, which is probability in unit 6. So I intend to release the project a little sooner this semester and see how well my students do, because normally I give students 6 weeks in a regular semester starting from week 10. But even with that, some of them don't get it done. So I'm planning to maybe release it in like week 7 or so. So like halfway through. Okay, so let's touch on exercise 4. So in this one, we're going to use string object. Okay. And we are again going to implement algorithm STL. So we're going to include that. And at the top, it talks about rotate. So rotate is a function that changes the order of the elements in the range of first and last in such way that the element pointed to the middle becomes the new first element. So there's some relationship with the position of the element in the string in this particular example. Okay. The way that it arranges it, it's going to point the element pointed by the middle becomes the first element. So for example 4, let me go to my REPL. And it is a little different than the other ones. In this one, you have a function, right? So here we include algorithm. And we have a function. And we're not returning from this function. So therefore, you have a void. And we are going to pass str, which is a string type, and out, which is a string type. Okay. Then inside the function, we would implement the control statement. So we would have the if and the for loop. Okay. So the if, you can read the comment that gives you the clue there. It says when the size of the str becomes 0, str out has the permutation length out of is n. So the if, basically we use it to control. Okay. So if the size of the string is 0, it's going to output the string call out. Then next we have a for loop. So here, right, I'm sorry. Oh yeah, this one, it has a return here with the if. With the for loop, we have, it's going to start at the 0 and it's going to go up to the end of that string. And it's going to increment each time. Now, permute came from the function that we previously defined here. Okay, so we simply call on that here. So it's going to remove, it says it's to remove the first character from str and add it to out. So every time it's going to take it from one string and it's going to put it into the other string. Okay? And for the rotate, this is a built-in from the STL. It's going to start at the beginning and it's going to do a +1 from the beginning, and then it's going to be the end, and then it's going to go to the end. So we pass the begin +1 and end. And in the main, we would then define our string str a b c d e f, and we would call the permute function in the main there. So when we run this, it's lots. So you have A, B, C, D, E, A, F. That's what we started with. Okay. And then on the next one, we have A, B, C, F, E. So it's now bring the F into the left of the E. And then after that, it's going to be A, B, C, E, F, D. Okay. So you should ask, where is the middle for this, right? Because when you use rotate, it needs to use a middle, and then it's going to point to the adjacent, that's how it's going to shift. Okay. So you would start. So the C is, after the C is where it's going to be the part. So you notice that it's going to start with D, E, F, and then D, F, E, E, F, D, and so on. Okay. Until here, after it runs out of the combination for the shift in these, where it would get to here, F, E, D. Now the F is going to be, now it's going to be in the descending order at this point. Then it's going to move the D, it's going to move the C to the last, right? And then the D over. Okay. So what happens is the last element in that string needs to shift until it becomes the middle. Okay. And then the middle is going to then shift to the last. And then it would continue from there. And that's how it's able to rotate all of the characters all the way down to the end, where you would have it all in descending order, F, E, D, C, B, A. And so this is another approach in how you would switch the letters, right? But in this case, we're using rotate function. Okay, so take a look at number 4, example 4. Now in my program, I have 2 letters higher, so that's why you see my permutation is more, right? In your program, you only have 4 letters. So to calculate that based on the example 4, your n is 4. And your n factorial is 4 factorial, which is also 24. Okay. In my program that I showed you, I have 6 letters. So that's why you see there are more permutation that was output. Okay, so 6 factorial in my program. So in your program, you should only have 24. After you calculate the total number of arrangement that it's going to give you, then you're going to run the program. give me the screen capture, describe the output in that program. And I think it's easier when you're looking at with less letters. Okay. You can play with it. You can add more letters to it, switch it around. Okay. Then after you describe the permutation output from the original program, then you can add more characters to it, which is what I showed you. I have 6. How many arrangement do you expect with 6 characters? Describe your output. So add 2 more letters, and your arrangement should be factorial of 6. Okay. And then describe your output. Now the screenshot, the answers, right? You can put all of them on one document. That's fine. You don't need to zip for me when you submit your assignment. Just either if it's a docx or a PDF, I'm fine. Okay. But if for some reason you take pictures from your phone and you attach the picture, sure, that's okay. Because when I receive a .zip, .zip is for like projects where you include your program files and documents and everything together. Some professor, they want you to zip everything up, right? In Canvas, we can't view it within Canvas, so we have to download it and then open it up. So it's better if you put it in the documents with your screenshot and your answer. Most of you do. Okay, so if you have any questions about submission, you can also email me. Can I leave the answers as comments in the program? Sure, you can do that. As long as you know to reference it later. Okay. You're welcome. So I don't mind if you put it in a different area, as long as I can see it, I guess, for the grading purposes. But this is also for you to come back to it later in case you need it, right? The notes, the exercises, this is for you, so you can reference later. My husband says that I spend way too much time on writing these notes in labs. But I think it's important to really show you how you should maintain notes as a college students and how you should, look at how to solve problems like these. So you can always cloud those for future use. Okay. Hey, we are very early today. This is kind of short, so let's see. Yeah. So make sure that you answer the questions, give me the screen captures as you complete the 4 exercises. Okay. All right. I'll stick around for questions, I guess, until later on. If you finish, you're welcome to type your name in the chat. Have a wonderful, warm evening, and I'll see you next Monday. Take care. If you have questions, you can ask questions. I'm here to answer. Okay, so there's a question that says, when describing the output for 4B, it will be considered ascending permutation from A, B, C, D to, yes. So it starts with A, B, C, D, and then it ended up with it should end up with D, C, B, A. It should start with ascending and finish with descending. That's okay. Because I was like, well, what did your program produce that? No, but I understand what you're saying. Can I put the program in ID? Yeah, you can use REPL. I use REPL. So if you prefer Visual Studio, you can use Visual Studio, NetBeans, whatever you like. You're the developer. Okay, to clarify 4C, how do we screen capture a long output? You can just scroll it down to the end part of it and then just screen capture that. That would be fine. I don't need like 5 screen capture. I just wanted to see, so you can do a screen capture of your input and your code and your output. That's okay too. But for your output, just scroll down to the last part of it, and because we wanted to see how it finished out the permutation at the end. Okay. Where would I switch to for IDE? So you wanted to go, if you wanted to use an IDE, you have to download an IDE for C++. But if you wanted to use REPL, you can just go to repl.it. Okay. And then let me show you if you haven't. So if you don't sign into REPL, I recommend signing into REPL because it saves your program on the cloud, right? Which is their server. And there's a limitation, but I have a lot of programs on here and they haven't, I don't pay anything extra. But anyway, so if you go to REPL the first time, it might ask you like for a language, okay? It will look something like this. Okay, so it's going to ask you like what kind of language you want. You just choose C++. And then if you wanted to make it like exercise, whatever number, and then lab number, something like that. And then you can just click create. And then there you go. Okay. And the cool thing with this is you can work in teams on this, and then you can, and if you wanted to download the file, it's on the left. Right? If you have file output, like if you have file stream, it will also store it here. You can also make folder directory, and then you can link it to your GitHub. You saw a little bit of that when I switched screen. You can fork it on GitHub. There's a lot of functionality with it. So you can do version control. You're welcome. Good night. I need help with have a mistake on 4. Okay. 1 second. Let me unshare and keep clicking share again. And if you want, before I answer the questions that the student need help with, if you want IDE, right, you can use Visual Studio, but you have to download and install it. The community one is free. And there are other IDE that you would use, but for this class, I'm fine with you using REPL. I don't need all the fancy IDE. I usually, for programming classes, I barely use IDE. I mainly use text editor. So you can use like Notepad++ and write your program and run it through command prompt or command line. But if you use an IDE, it helps you debug it. It highlights the error or it points to the error. So that helps too. But REPL will tell you that. So you would use repl.it. And then there are other ones. You can search for C++ online compiler. I like this one the most because it seems the interface is easy, and there's, you can use it on top of the other web-based application, and you can use it for other programming languages like Python, JavaScript. Okay, Sarah, do you mind sharing screen? I think it's a syntax, but
Yeah,
hold on.
I was gonna ask if I can share my screen.
Yeah, okay, you should be now.
I have this, and right here is my mistake, but I'm trying to figure out what my mistake is.
Okay, so you have the issue with rotate, begin, indentation. So for the body of the for loop, for future references from number 19 to 21, you should always indent in the body of a loop. Okay, so when you have those curly brace, right after the for on line 17 is where the beginning, that curly brace just represent that it's enclosing the body of your loop. So a good practice is to indent 19 through 21. So if you're using this, if it's not recognizing rotate, let me see, I think it's something is funky in that part. 1 second.
How do you indent?
Tab. So you need to indent in from that area, because sometimes indentation, so put your cursor in the, no, not that one, line 19. Tab. Okay. And then again for the other 2 lines. For rotate too, because that's the, yep, I just saw that too. You have 2, not 3 parameter. So for the rotate has 3 parameter, begin +1, and end. You're missing the str begin. So right after rotate and the parentheses, you need to add str.begin. So after the parentheses, yeah. No, like the next to rotate, the open parenthesis. Oh.
Right here?
It tells you in the console, Sarah. That's what Eric is saying. So yeah, so when you look at the error, it points out to you that you have, yeah, so somebody just typed it in the chat for you. Juan Lee's typed it in already. So you would have rotate str.begin, comma, str.begin +1.
Oh, I need 2.
Yes, you need to have 3 parameters, not 2. Okay. Yep, that is it. And if you look at the right-hand side, it gives you a clue on why that's wrong, right? It tells you, where the little green caret under, it points, yeah, yep. And then below that, it says 2 were provided where it requires 3. Okay, so, and it tells you the line where that's at. So what that does is it helps you debug it, right? You would refer to that message and you say, okay, I need to go to that section of my code and I need to make sure that I fix the parameter.
So it will always let me know right here where is my mistake.
Yeah, so the all IDE, so that one is an online compiler. It would tell you, but even in a regular IDE, it would tell you what line you would have as wrong or needs to be fixed. You're welcome. But remember, loop got an indent. All right. Okay. Any other questions? Thank you everyone for your help. Can I get a link for the event you mentioned earlier? Yeah, so the competition, are you talking about the sorry, I show my Linux machine that's running. It's in the announcement. You can find that here. Oh, you're welcome, Sarah. So if you wanted to compete for the programming challenge, okay, that is there. And then if you're interested in live after 5 for the thing, I'll put it in the chat. Okay. So this one is a programming challenge where you can do like bug bounty. And then give me 1 second. Let me pull up the link for it. So and from 5 to 6, they always have presentation of different companies, different organizations. So if you want to learn more about cybersecurity, I'll put in the Zoom, and you can also register for it. But here is, so live after 5 is so this week we are doing California Mayor's Cup, and it's a cybersecurity competition to basically defend a network. It's very similar to the National Cyber League or the NCL. So this year we're running our first college division under California Mayor's Cup. I was able to put together a small team that's going to be competing on Saturday. So they compete live from like 9 in the morning until 3. And they're given like questions to solve, right? Like if somebody's attempting to hack them, what would they do? They need to configure it. So as they go through the competition, they will be presented with different criteria and they have to address it. And the team that has the most points will win some kind of prizes. NCL is a little bit bigger, and I didn't participate in NCL this year because I got a little busy, but I normally coach or help out with one team. But if you wanted to check out the presentation live after 5, it's for the Mayor's Cup, where different school, different professionals, different people go and they talk about cybersecurity, what kind of skills, you know, the type of jobs that you would be doing. So UCR, they presented today. Their cybersecurity engineer presented today. And then Booz Allen and Cisco presented today. Tomorrow it will be different group of people. So that link is to the Zoom presentation, and it starts at 5 p.m. goes until 6, and it's about 10-15 minutes per group. So, and I'm going to be presenting on Thursday, and then from 5 to 10, 5:10 or 5:11, and then I have my former students that's going to come back and present from 5:15 to 5:30, and then we have another company presenting. So this is coordinated by Syned, and they help us with cyber camp and other things in the region. So, okay, but check out the competition. So is there, yeah, it's presentation every day from 5 to about 6 something, from this whole entire week until Friday. Okay, and if you like, you can watch the presentation. It's good to, you can win prizes when you come to those. Cisco was giving away some stuff earlier. You're welcome. Thank you. You're welcome. Any other questions? Thomas, you doing okay? You're welcome. Bye. Mario. Let me pause the recording. Thank you, Eric. Have a good night.